Okay, ecology, let's go into core concept number 2, where we are looking at the combination of global and regional variations in temperature and precipitation that determine the location of biomes. So, what we're doing here is a combination of biome characteristics and baby climatology. Your first learning objective: state the two large scale factors that determine the climate and biome at a specific latitude. And I want to go ahead and clarify this because some people were working at a very, very large scale, almost like from outer space on quiz number 1 with this, whereas others of you were working on the scale of the northern and southern hemisphere. And just for our intents and purposes, I'm just drawing the northern hemisphere because that's what I'm holding you responsible for in terms of the biomes as well as the climatic patterns. So those two large-scale factors, we have incoming solar radiation. And yes, incoming solar radiation is what drives the climate system. But the two large-scale factors that are set up by that latitudinal variation in incoming solar radiation are temperature and precipitation. Whenever you get down on a smaller regional scale, your factors of the landscape that can influence the climate and biomes in a specific region, the presence of topography or mountain ranges. Not only does that create a rain shadow, but you also have what's called the substitution of elevation for latitude, the fact that it gets colder the higher up in the mountains that you go. And then the second landscape feature is the proximity of an area to a large body of water, understanding that large bodies of water will moderate or with the word moderate, we're talking about make it more habitable, make it more, I hate to use the word pleasant, but it is, if you will, a calming or a steadying effect that is created by the weather systems that will come in off of those large bodies of water. When you illustrate and explain how solar energy drives global patterns of temperature and precipitation, this is that figure where you look at the amount and the consistency of incoming solar radiation there at the equator, how that heats the air, causes the warm air and the water vapor that is being moved through the ecosystem by both evaporation and transpiration. You get this large amount of water vapor that evaporates and transpires. It condenses higher up in altitude, falls back down at precipitation. And then what we get is the descending warm air at 30 degrees north latitude. That over here on the continent of Africa, the activity that we worked with explains the location of the Saharan desert there at 30 degrees latitude, and it also influences the presence of our southwestern deserts here within the United States. Several of you went ahead and took this further to where as that warm air rises here in the temperate latitudes, it gains precipitation again, which drops here in the zone where we see our temperate biomes, both temperate deciduous forest as well as grasslands. And then it descends again up here at 60 degrees north latitude as cold, dry air. So moist air is rising at these two, let's see here, at these two areas and at the equator and also in the temperate zone with the amount of precipitation condensing and falling out in those areas. You get the descending patterns of dry air that is warm and indeed hot over deserts at 30 degrees north latitude, cold over 60 degrees north latitude. In terms of now taking this into biomes, soil is broken up bedrock. Soil is the foundation of your biomes. And moving on to that next learning objective, there are relationships between the climate, the soil, and the biomes. And all I'm holding you responsible for on those is what you see in those major characteristics of each biome as you go through the slides that accompany core concept number 2. Wrapping this up for this review video, I ask you to label the general position of each North and South American biome along the gradients that we discuss. And remember again, that north to south gradient is a gradient of temperature that corresponds with latitudinal change. And so you're going to go from the tundra to the boreal forest to the temperate deciduous forest to the tropical forest. Your east to west gradient across North America is a gradient of precipitation, with higher amounts of precipitation in the east, lower amounts in the west, and the corresponding biomes going across there, beginning in the temperate deciduous forest. You then move into temperate grasslands, into chaparral, and also into deserts. So that's our review of core concept number 2.